let's start. This is a Lelit Bianca. I've taken the case off and it's viewed from the top rear. Yeah. Here is the steam one. Here is the E61 group, and you just see the paddle there. And lastly, there's the steam wand on the far left. Okay. Now, I pointed out the E61 group here. This larger pipe is the top group thermosiphon pipe, and it's actually quite big, which is a good thing because it allows for a small temperature offset, which is a great thing in an espresso machine. It leads to the top of the brew boiler here. Now it's slightly awkward to see, but can you see the brew boiler's not upright, it's inclined, and that's not so they could fit it in the machine, and it's not a mistake. It's inclined to prevent airlocks stalling out the thermosiphon loop. If it was upright and you had even a drop of a few millimeters in the brew boiler, because the pipes usually don't go down into the boiler a few centimeters, they're just at a top fitting, any air at all stop the thermosiphon loop. This is a problem on more espresso machines than I'd like to mention. By inclining it, it means that even if air gets in, the top where the fitting is pretty much always covered by water. Okay, looking around the rest of the machine, we can see the steam boiler here. Yeah. Oh, I should have mentioned this pipe here is from the pump, and it obviously feeds in to the brew boiler. Okay, and pumps the water in. That's your steam boiler here. On the top of the steam boiler are your various fittings. Obviously, this is where the water enters the steam boiler, and this solenoid here either diverts the water to the steam boiler or the brew boiler, depending on what's selected. This other solenoid is the Lelit weird depressurization solenoid that no one else has, that actually depressurizes the brew circuit just so the gauge shows 0. I mean, this cost Lelit money to put that in, and I've really never seen anybody do it. I think it's great they do, because it shows an attention to detail, and I like that. So that's your water entry into the steam boiler. Let's clear those away. The next thing here is 1 and 2 limit stats. That's a safety thing. You know, 2's got to be better than 1, but if 1 fails, another one will work. This here is the capillary tube that's the takeoff for the steam pressure. This will be a safety valve, and that will actually vent outside the case. That's why it's got a tube on. A lot of them used to vent sort of inside the case, and all the electronics, not great. This tube here, this expansion valve, when you heat water it expands, and if you didn't have the expansion valve, when you heated the water in the brew boiler, it would split pipes and split boilers because it's relatively uncompressible. This valve's set to about 12 bar, and the water again trickles out. All these tubes lead to the drip tray in the end, and then I'll clear these away. And the last one here, that's a cap on top of the vacuum breaker, so that as it sputters, as it closes, the water again doesn't spray around the inside of the machine, which can sometimes happen. And you know, it's good practice to vent it to the tray. The next thing here is your thermal sensor. This is what picks up the temperature, sends it to the Guy car box, and a little dial on the front of the machine. That's pretty much everything on top of the brew boiler. Oh, these little limit stats, they're called. If the temperature goes over what it should, the electronics for some reason don't pick it up, then these will pop out. They're normally set at about 145, 150 degrees. And if you ever, for any reason, find it's not heating, just check one of these limit stats hasn't popped out. If it keeps happening, of course, you've probably got a problem. So there's the 2 limit stats, and you could always check that they don't need pushing in. Okay, moving to the brew boiler, you can see another limit stat there. Oh, I should have mentioned this and this black stuff. They're insulation jackets. They keep the boilers insulated, which is a good thing. And this limit stat again can be reset just the same as the other one. The plate you see here is becoming more common in espresso machines. They never used them, but that's a reinforcing plate, prevents group flex. In fact, there's more than just one. As you can see on the Lelit, there's two. There's another one here. You can see that's the front, but then there's one plate, and then this second reinforcing plate. This is just to try and prevent group movement, not because it's harmful, but because people don't like it. I don't like it. You can just see in the background, just there, that white thing, that's actually the pump capacitor for the rotary pump. That's the start run capacitor for the rotary pump. In general, the machine's pretty uncomplicated. The wiring's fairly uncomplicated, and it's all good quality stuff, all good quality silicon wiring. On the case here, this and this show the locator areas. If you ever do take the case off, very important to get the location of the case back accurately, and there's a little like a shaped piece that fits in there, and it should come up absolutely level. Okay, once a year I recommend, if you can, you take your case off and you check everywhere for leaks, because if you can fix the leak early on, it ceases to become a much bigger and more expensive problem elsewhere. The last thing, that's a little thermal sensor for the brew boiler. The reason it's not at the top is that's not the best place for it. The best place for it is down in the middle of the boiler, so some water mixing has had a chance to take place. I should add as well that this expansion valve isn't for controlling brew pressure and is not what you adjust to adjust the maximum brew pressure. If you adjusted it, it would and could adjust maximum brew pressure, but it would cause a lot of flow of water into the drip tray, and this is not its function. It's set to 12 bar or 12.5 thereabouts, and should be left alone because it's simply there to prevent damage caused by water expansion when heating. I can't stress that enough. Now, I do have a confession to make, and that is the machine I was sent got damaged in shipping, which is a great shame. I'm really, really upset about that. However, and the damage is here, as you can see, and it bent the bottom, and there were other areas of damage. Fortunately, it could photograph okay. Not perfect, so if you think, oh, something's not quite right in the photograph, that's the shipping damage. But internally, the machine was strong enough to stand up to some fairly significant damage, and I was able to complete the review because it still worked, which was fortunate. So anyway, let's talk about the back of the machine here. I've covered the components on the top. Some things that were added. There's a little shield, water shield here added so that we'd keep this dry in the event of water spillage. A good thing, because this is your Geicar box. They're not cheap. This really is the autofill controller and the brains of the machine, if you like. What you see on the front, the little round thing, I believe it's OLED, is just a display device, and the intelligence is in this box. Now, you can see that the steam boiler is a fairly squat boiler, and your water level would probably be up at about here. They're about 70% full. Yeah. Your takeoff pipe is right at the bottom, which is great. It'll actually poke up a little bit into the boiler, so it won't allow you to drain it completely. But it's pretty good if you want to descale, because it means you can give most of the water out. If it was set too high, it makes descaling quite tricky. These top, the boilers are ISI 316L low corrosion steel, which is a surgical grade. The top plates here are 8mm thick, the boilers themselves are 1.5mm thick, so pretty good quality. This pipe here is your takeoff for brew pressure. Okay, and that's why that solenoid, when it activates, depressurizes the brew circuit. So when you put the lever down, lever flicks back to zero, the needle flicks back to zero. I like the mains connector here, and I straightened this because I couldn't get the plug in, but this was before I straightened it. The mains connector here is like a plug-in kettle lead. I much prefer that on espresso machines. It's so annoying to carry them about and have a mains lead dangling around you can't get off. It also means the mains leads are wrapped around in the box, and unless if they don't fit a protector, can scratch machines. So I much prefer this, much prefer this. And it means if you move to another country, you can just buy a new lead, you know, for that country. Now, here is the captive nut, so the feet are adjustable now, which weren't on the prototype, but they are now. Some of the electronics, the SSRs, solid state relays, they're hidden away here in what should be a fairly dry and cool area of the machine, as you'd want. The other thing as well, the boilers are reasonably well supported, plenty of water metal supports, because you may not realise that the boilers are heavy, and if a machine does get jiggled around in transit, if it's just held by the tubing, it's very easy for things to sag and move out of position, so it's nice to see that sort of support. The side view here shows the motor, and it's really tucked in there, and you get a better view of the incline brew boiler there. You can see it much better how inclined it is. As I say, it's to stop airlocks, not to fit it in, as a lot of people will think. You can see clearly now the SSRs, yeah, solid state relays there. Obviously they're bolted to a plate in a cool area of the machine. That just allows effective heat sinking. And here's the back end of the rotary pump, and you can obviously see the reason why the capacitor, which is normally mounted on the pump here, is mounted up there, because it's really had to be shoehorned in. One thing they have done, and I looked at the pump mounts here, used a really good set of pump mounts, plenty of rubber in there, nice long pump mount, so that the pump actually has mounted very quietly. It's not touching anything. Really quiet. Yeah. Well, what this is actually, I mean the motor, because this isn't the pump. This is actually the motor. What you're seeing here. Yeah. We're going to move to a view the other side, but before we do, as you can see here, some of the mounting pieces to hold boilers and everything in place, and the steel of the frame here is actually pretty thick. This is what makes it quite heavy. It's a good thick steel frame. So now we're back to the pump side, and you can actually clearly see the Fluiditech Rotaflow pump. These are sort of specially made pumps for prosumer machines. They all pretty much have this pump. It's a smaller size pump, slightly less gallons per hour flow rate, but ideal for single group prosumer espresso machines. Now, before I talk any more about the pump, here is the access hatch for dropping the heat element out of the steam boiler that you couldn't see earlier. Okay, this pipe here is the inlet pipe, and underneath is where either the movable and removable tank has a silicon pipe attached, or if you remove the silicon pipe attachment, you can screw in the high pressure fitting for mains plumbed operation. So that's the inlet to your pump, and here's the outlet to your pump. And the water flows along this pipe and to the rest of the machine, either to the brew circuit or to fill the steam boiler if it needs water. So let's clear those away and point out this. Now, you can't quite see the bottom of it. There's a black plastic, hard plastic nut there. That's a lock nut. And underneath that is another 10mm nut with also, it's got a screw slot in it. This unit here is called the balance bypass, and what it does is to limit pressure on the rotary pump if you reach the limits of what this is set to, and normally it should be set. Normally 9 bar, but on this particular machine you'll want to set it to 10 because of its ability to profile, and that's important. I found 10 bar to be a good setting, and I explain why later, probably in the review and certainly in the user guide, why that's the case. But trust me on that, 10 bar is good for this. In here, once the resistance reaches a certain point and the pressure's up to 10 bar, if you didn't have a bypass valve, these vanes inside the pump would shatter. And what happens is, as the pressure increases, it drops across the bypass here, yeah, through a channel, and there's a spring and a plunger here. So once it's above the 9 bar in the system, the water actually starts to flow around this area. I'll put another arrow to show you. and another arrow. So the water starts to bypass and recirculate through the pump, which is okay as long as it doesn't do it for too long, because eventually that water gets hotter and hotter and hotter just by the mechanical agitation of the water. So inside here is a little plunger, a spring, an O-ring and a channel basically, and it's just the pressure of water here, once it gets above 9 bar, pushes the piston down and opens up the channel and allows the water to circulate. Hence it's called balanced and bypass. Okay, and that's how rotary pumps work. Vibration pumps work differently. What they do is they dump the water, the excess water, via an expansion valve back into the tank usually. So a lot of people do make the mistake of thinking in a rotary pump machine, oh, I should adjust the expansion valve for pressure. Not in rotary pump machines. That expansion valve is used for water expansion and the high value of hydraulic pressure that can be generated. This under here is what should be used to adjust the maximum brew pressure. Now, you theoretically should lock this black nut back up, but it's a ball ache if you do to try and get to it again. So I never bother locking them up, and I don't find the setting tends to move. I just use a 10mm spanner and adjust the one on the bottom. And you can reach it from underneath the machine, so there's no need to take the case off. So if you look on the bottom right of the machine at the midway point, you'll actually see that adjuster underneath. Okay, here's a view at the bottom of the machine from underneath, and one of the things you can clearly see here are the heating elements. I'll just indicate those. One there and one there. And the little white bit you see there is a Teflon gasket for the heating elements. Now, what's nice is they've thought about the fact that you may need to remove them one day. And you can just see here, and the screw for it, an access hatch, so you can get a socket up there and get the heating element off. And there's a second access hatch, if I move that, in this area as well, so you can get both heating elements out. Now, it might well be necessary, if you can't remove fittings and suck water out the brew boiler here, that if you ever do want to descale it, the best way is undo the heating element and just let the descaler out that you've pumped into it. I'd be inclined to try and remove a fitting and suck the descaler out. In fact, I'd be further inclined to not let it scale up in the first place, because that'd be the ideal situation, yeah? For the steam boiler, as I said, this fitting probably doesn't go up very far. You could probably fill that with descaler and then switch the machine off, open the water tap, and probably get most of that out to about there, and 3 or 4 fills, you've probably got most of the descaler out of it.